So this time we're going to analyze the other log files, and this time we're going to use awk, find, for, and some regular expression, some Python as well. So let's go get. And we already analyzed the attack.log, although we didn't finish, but we already find an attacker, what kind of tools he used. So we answered the pretty majority of the questions. Of course, in real life, you may need to prepare some kind of nice looking report in order to report to your manager or customer. But for this moment, let's assume that we already solved the case. Our reporting and paperwork is easy to do. All right, this time we're going to look at the u_x, and the other one is u_x, two files. These two files, we're going to take a look at them. So again, we're going to use the same methodology. First of all, let's look at that. How big are these files, right? So it says that 30 something, 70, 87 something, but how about human readable format? And as you can see, guys, it's 30 megabytes and 84 megabytes. So if I do this word count minus L, and if I say UX tab, as you can see this time when I tap X, press tab, it comes to a point, but it's not completing the all, because there are two things start with u_x1, right? So we need to say something, either it should continue with 4 or 5. If I say 4 tab, it's going to give me this something, But there is an easy way to do that. Let's assume that there are hundreds of logs under this directory, right? It's possible. So in this case, if you wanted to get the word count of all log files, there are few things that you can do. First of all, you can use a wildcard. Pretty majority of the Linux command lines understand a wildcard. So in this case, for example, it's possible that I can put a star at the end. So if I press enter, it's gonna give me the word count of all u_ex files, right? So the first one is 283,000. The other one is 131 lines. So 1,000. So so there is another way to do that. So I can use wildcard, but wildcard may not work sometimes. So let's assume that I am in a position that one of the file is actually, let's copy one of the file ux1, let's say 4, and I'm going to copy this another file, let's say mylog.txt, right? Let's use find first. Find under this directory, and I'm going to say that, and name is equal to something like this. Either ends with star.txt, so I can do that minus exec and cat curly braces and backslash semicolon, and then I can say that grep, or let's say instead of grep, word count minus L. So it's going to do this. It's going to find all txt files under this directory, and it's going to count. Of course, it's same for log files. So for example, if I say log, and it's going to give me this exactly the same thing. But this time, remember, it's accumulating the number of lines. So for example, 442,000, which is the total of these two, and also the attack log. So it's also a log file. So if you're interested in only u_ something, you can say that u_ex. Okay. So this time you're gonna get only the ux files total, right? So here, for example, you got the total. Okay. So what else? So if I need to, for example, find this log and the ux files, what can I do? For file. This time I'm gonna use for, and for file in. Actually, this is let me start with an easier example. So for a variable, let's say x, in a range of something, right? Okay, and do here I'm gonna do something, and then done. So this is a template for in do done. Okay, so this is a template. You can put a variable here, and you can play with that variable at here by using a $sign at the beginning. So for example, if I assign something in this range, let's say here we have a range. So this range is going to be assigned to x one by one, and this x is going to be used on in this statement right here, and I'm gonna terminate with the done statement. So how is this possible? How can I do that? So let's use exactly the same syntax. So for example, I'm gonna say that for x in, let's say 1 to 5, okay? So do echo and let's say $x and done. So this is the easiest way to use a for loop. So 1 to 5 are the numbers are going to be assigned to x, and I can use x as a variable in this function, in this statement. So here echo x means that echo the x, whatever it is, and each iteration it's going to be incremented one by one. So I'm gonna get the 1 to 5 numbers, printed into console line. So this is how we can use. So I can use another statement instead of range here. So for example, okay, this time I'm gonna use for file. So for example, for file and star.log files, do word count -l star.log and done. Okay. So it's not going to be star.log. Instead, it's going to be file. Okay. So here, as you can see, guys, so log files, it's printing. So this time I'm using the iteration. Of course, this is also possible. Instead of saying that, I can put some statement here. For example, I can evaluate this statement and let's say ls star.log, right? It's exactly the same thing. I'm finding the log files. It's going to be an array now, and it's going to be, this array is going to be assigned to file object one by one, and my file object is going to be used in the word count line cell. So it's exactly the same logic. Okay, let's see. All right, so we'll look at the let's say tail -20. So we look at the for and also find. So there are ways to do that. If your log file is under multiple directories, under multiple numerous name format, it doesn't have to be in some format. So you can do whatever you want by using the find and for loops as well. So okay. And now I'm gonna do is let's remove this because it's a duplicate of something. So I'm gonna analyze these two log files. So can I analyze together in one shot? So that's exactly possible. So for example, I can get the word count -l of the ux star here. Okay, we're talking about 414 thousands of lines, so it's not possible to analyze with a notepad. In reality, actually, we'll see a much larger files. Actually, if you're facing with the 84 megabytes of log files, it's fantastic. So you can do whatever you want that file. But in reality, you'll be facing with millions of, even hundreds of millions of log files. It's possible. So we get that. So let's take a look at the beginning of each log files, right? So I'm gonna do something similar to word count u underscore something star. So as you can see, guys, head and tail also can understand the wildcard. So I'm looking at the header of this log file here, and the other one is right here, right? So that is possible, and you can see, guys, both of the log files are the same type of log files, right? So Microsoft IES 7.5 log files here, one of them is captured at this time, the other one is captured at this time. So it seems that they are not continuous to each other, so you can analyze one by one, but let's assume this time we are looking at the same thing simultaneously, right? Okay, so what I'm going to do is I'm going to look for, again, some kind of attack vectors, but we already analyzed a SQL injection. This time I'm going to analyze cross-site scripting, and I'm gonna find SQL injection vulnerability. So let's start with cross-site scripting. What is it? What kind of keywords can I find in a log file? So let's refer to our library again. OWASP, say that. What is it? Okay, yeah, cross-site scripting. This is actually a kind of inserting a JavaScript or HTML code in your code user interface. Unlike SQL injection affects the server side, but cross-site scripting affects the client side usually. You know, the attacker infects the client and, you know, get something from the browser's victim's browser. So, and some of the famous tags or the patterns in this cross-site scripting is this big, greater than and smaller than signs, and also script tags. So these are pretty famous in cross-site scripting world. So we're looking for these kind of characters, right? So let's find it first, okay? Let's grab some script and script keyword, and I'm gonna ignore the case under my u underscore star file, and I'm gonna say look at for more. So it will help me to, you know, analyze slowly. Okay, as you can see, guys, I see some JavaScripts here. So jQuery is fine because it's under scripts directory. It's not a big deal. But here we have an interesting one, right? So script alert one script, right? So this guy is actually trying to do something on my server, and my server is 172.168.52.101. So this guy seems an interesting one, right? So let's analyze it. What kind of requests is he sending to my server, right? Okay. So of course we can look for a greater than and smaller than sign here. Let's do that also, and I'm gonna do greater than, smaller than, and yeah, let's look at this, and I'm gonna do something, and I don't want to see this type of result. So if it says something scripts under jQuery, so I'm not interested in this kinds because they are false positive for me. So what I'm gonna do is I'm gonna eliminate those things and look for only these types of grades. So we are not getting any results because we did a mistake here. We need to put a regular expression because it has to be evaluated as a regular expression, right? So let's look for the results. Okay, so our attacker is exactly the same IP address. Is trying to do something, right? Here, for example, it's looking, he's looking for an alert. He's looking for hello here. So obviously he has some bad intent. Let's investigate this guy, right? So what I'm gonna do is I'm gonna grab this guy in my u underscore files and star, and I'm gonna say more here. So okay, so interestingly, we were looking for something, but I got something else. So it's as you can see, guys, it's looking for product.aspx here, and now here is the interesting part starts, right? So he was looking for product ID 18, and then notice the query string here, right? The query string is something strange here, and if I continue that, I'm gonna see something really strange here, right? So what kind of attack is this? It's obviously a SQL injection if you guys are familiar with URL encoding. So this thing is actually a URL encoded string. So let me copy this, and I'm going to show you something online. So you can find it online. I'm going to show you some console as well. So URL decode, and let's use this. I hope is this something useful. Okay, yeah, here, and I'm going to say decode. So see that, guys? Product subcategory 18, and then triple parentheses and a number equal to a number, and another triple parentheses and number another equal to another number. So obviously my application is not working like that. So it's a partial SQL statement. He's trying to SQL injection to my server, right? And interesting here, I'm looking at some HTTP. Where is it? HTTP 404, 403, 403. Let's find more here. Okay, yeah, billion, and another SQL injection parameter. So it's obviously I can't analyze this, by hand. So I need to look at the what kind of request he's sending me, right? Obviously, he's working on the product subcategory ID right here. So I need to take this parameter and decode this parameter, and I can look at that closely and I can understand it, right? So what I'm going to do is I'm going to grab this IP address again, but this time I'm going to get the only that part, right? So I will use again the cut. So and the field, what I'm looking for is at let's count it. Okay, this is the first one, second, third, fourth, fifth, sixth. Okay, let's see if it is sixth or not. Let's use only add. I don't need more. Okay, yeah, it works, I think. So it's obviously a query string. So, and let's get something interesting, because let's grab here, grab ignore case product, right? So because he's trying on product side, obviously there's something pattern, but I can't use an online tool to decode all these strings on a website, right? Because it may include some sensitive information. You don't want to do that, because it might be first, there might be a lot of numbers, right? Let's assume that there are 10,000s of lines. It's impossible to paste it in there. And secondly, it may include some passwords, some sensitive information. You don't want to share your customers or your company's information on an online service, right? So that's why I'm going to use a Python script here. I have this one I'm going to share with you guys as well. So I have a URL decoder, easy peasy to use, Okay, and put some code here. So let's summarize this. Python evaluate a command here and import two libraries, system and also urllib. And urllib is going to be ul, and it's going to print ul under ul, library function called uncode, and it's going to read from standard input, right? It's pretty straightforward, easy to use a Python script. So let's see the results. Okay. Okay, so yeah, it's had here. Okay, all right. What I'm gonna do is let's get some head here. Okay, because the performance issue, right? If you get thousands of lines and use Python script to decode them and then use a head again, it's going to cost you more. But this time we're changing the head statement. We are reducing the number of lines to submit the Python statement. We are reducing the process time. So okay, yeah, we have something really interesting here, as you can see, guys. So this time it's obviously readable. And let's get some more lines here, right? Because 10 lines it may not be enough. If you say that had -20, it's going to give you 20 lines. Okay, and let's get something from tail, right? Oops. This time from the bottom, I'm going to use tail here. Okay, so this time grep is processing all the lines and bring me the bottom of the line, and then you're getting the result. So at the bottom, I'm looking at really interesting statements right here. For example, product and percentage encoding of SQL statement. As you can see, guys, there is a SQL null, a select null, something when is. So this is obviously an SQL injection statement. Another one is actually, as you can see, union all select null when is, it's another SQL injection statement. Here's another char encoding here. So obviously he's trying to do some SQL injection, but can you find that whether our server is really vulnerable to SQL injection or not? How can I detect that, right? So first of all, you need to look for the return results of your file. So for example, if I look for our files, you will see that at the 12th column there is the HTTP response code, right? So you need to know how your application is responding. So this time, instead of getting the whole things, what I'm gonna do is I will get 12 column as well. So this time, yeah, let's do that. And yeah, let's get head here. So it's, I think it's wrong column here. I think it's 11. Oh, sorry, it is 11. Yes, so 403, 200. So here's the thing. I need this 403 at the beginning of the line so I can sort that. I can see the 500 at the top and 200 because 500 are the most dangerous, return statement. 403 is the second. If you are getting with 300 or 200, they are not that dangerous, right? So we need to identify whether we have any 500 results, right? So let's take a look at that. But I need to shift 403 to at the beginning of the line. So how is this possible? Unfortunately, code cannot help you on that position, but instead you can use awk here, right? Awk is the very similar thing, but this time you can use regular expression here. Okay, that is possible. You can use multiple delimiter, for example, space and let's say space and I don't know, maybe a sharp sign, right? So you can use multiple delimiter here as well, but I'm gonna use a space, and then you can get whatever column you want, right? So for example, here I can print the first column, pardon, second column, pardon, 11th column, and let's say I will put some space dash space here, and then I'm gonna put dollar sign and fifth column, sixth column, yes, sixth column. Let's see how it look like, right? So here I put the HTTP return statement at the beginning of the line. So I can use my sort statement, and then I can get the result, right? So for example, if I say sort minus n, this time numeric sort instead of ASCII sort. So because these are number at the beginning of the column, these things 200, 403, those are number. I need number, and let's get some head here. And if I see any HTTP 500 something, then it means a red flag for me, right? Let's see. Oh, okay. So I'm getting 200 because I didn't say that reverse sorting, okay? So let's reverse sort these things. Okay, yeah, wow. So see that, guys? We have some HTTP 500 here, and we have some, statements here, right? It's working. So what kind of statement here? Obviously, they are both URL encoded and also Unicode encoding. So we have double encoding here, but I don't interested in the, statement or the partial SQL query here, but I'm looking for something special. It says 500, okay? So we have a problem here because our application is not handling 500, I mean the SQL injection statement very well, right? So we are getting some 500. We need to take a look at our application's behavior. If our application is handling in a 500 page with a regular way, then there is no problem. But if I am not handling SQL injections very well, and I'm concatenating SQL statement, uh, those are some parameters are coming from user side and some parameters are coming from my code side, then there is a problem that it may result in SQL injection statement, right? So I need to think about that, and I need to take a close look at something. So how can I identify that these SQL injection attempts are successful, right? So there is a way to find that, at least for this example. So what I'm going to look for that, I'm going to take a look at the process time, right? Because majority of the SQL statements, they always try with the wait for statement, they try with Boolean statement, error statement. So this time it's obviously that 500 is some problems. And of course I can decode that with my Python script as well. If I say product ID is equal to 18 and then drop everything, then it's gonna cost us, right? Let's get rid of this. Okay, product subcategory is equal to 18. I think these are post statements probably. So here, again, 200, but this time end this statement, right? It's working. Unlike the other statement, this is successful, right? And order by 10 dash dash, order by 1, these are successful. And this one is also successful, right? Because it's HTTP 200. And interestingly, these are also successful, right? Wait for delay, something, something, right? So that's also interesting story here, because our application is responding wait for statement and order by and something, right, with HTTP 200, and those are really, red flag for us. So let's take a look at these statement, right, because those are interesting ones, and I'm gonna specifically look for this one. Let's copy this, and I can prove that this statement is work, because if it took, let's say, 5 seconds or close to 5 seconds, that means that this thing worked on the, executed on server for 5 seconds, which means there is a SQL injection exploitation 100% available, right? So let's take a look at that. Let's cancel this, and this time I'm gonna look for something. Grep, okay, and grep testing, wait for, and I need also the execution time, right? Execution time is at the very end of the log file. So this is the log file, the execution time and the log file. So it's let's count this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, it seems 15. Let's see, and I will put that here as well. So $15, and then another placeholder, and then I'm gonna get the 6th column. Okay, so let's take a look at that, and I'm gonna use the more again. So this time I don't need Python, but let's keep it in place. Yes, it's 14 here. So don't think about that, because this this thing is actually starts with fields and then another space. So that's why the header is shifted 1 column to the right. So although it says SC Win32 status, it's actually time, because this thing is actually shifted 1 column. Okay, so then our column number is 14. So let's get 14th column here. Okay, it's already 14 in my script. Okay, here's the interesting thing. So where is my, the HTTP code and also the time taken, right? Those two are missing here. So that is because the 14th line, it actually has a carriage return at the end. So \r is at the end of every line in this log file, right? It's also another character. If you try to compile with that, it may result in something interesting here. It's actually overriding itself. So what I'm gonna do is I'm gonna get rid of this character. So how can I do that? I can do this with set statement. So set actually takes a takes a lot of arguments to replace that. The syntax is pretty straightforward. If you say set and also in between 2 quotes and between SG here and 3 characters here, it doesn't have to be tilde, but try to choose less used characters, right? You don't choose the A, for example. A is pretty much used. So I can use this one is possible, or even slash is possible, or even you can use let's say semicolon. So those are possible, but I prefer tilde. Okay, what I'm gonna say is, if you see \r replaced with nothing, okay, if I say here, for example, it's going to be replaced with here, right? But I don't need any character at the end of the line, so it's going to be only a empty string, right? So this time, if I run this, I will get something good results, right? So we are looking at an absolutely successful exploitation because this wait for statement is actually getting a parameter 5 seconds, and this execution is approximately taking 5 seconds, right? So it means that you are returning with HTTP 200 here, and also you are getting a 5-second execution time, 5,000 milliseconds, means that this exploitation is successful. As a result, therefore, this guy is, exploited your servers in a successful way. That's a SQL state, injection. He also tried with the cross-site scripting, but we didn't see any successful cross-site scripting exploitation. Maybe it's in the post sections, but since we are looking at only the get logs here and also get URL queries here, unfortunately, we don't have the post body here. Therefore, you can't see that, right? But you can see the post body in web application firewall logs, or if you are, have another lock statement to lock the post body as well, you can see that. But for this moment, let's assume that we don't have it, so we can, uncover potential exploitation with post, but this time it is obviously exploited with get statement. So let's answer some questions here. The attacker is this guy. He tried to exploit some SQL injection here, and we see that he is successful. He found a successful SQL injection exploitation. And let's see how many requests he sent it to our server, right? So let's copy this and let's say grab this guy from our u_star, and let's say work count minus out. Wow, he tried a lot, right? So let's investigate what kind of tool he used, right? Let's take a look at the user agent and also the referrer and also the time of this request, right? So for example, I'm gonna get something here. I will let's take a look at step by step for now. And as you can see, guys, it's under UX 15.02.17. And it started with 932 and it goes on all the way down. So he started with this normal request. It requested the root directory and then some CSS and JavaScript files here, and then he visited this URL, right? Okay, let's continue on that. And then he tries something interesting here. So for example, %27, which means that, single quote, right? Single quote is a famous SQL injection detection. So he tried something and he gets something 403 right here. So that's interesting. He was getting 200, he gets a 403, and he decided that, hey, something is interesting here. Let me try something else. And he began to investigate it, right? He's getting a lot of 403 here. And if you look at the times here, so this one is at 9:32 and then 9:36, 4 minutes between two of them. So which means that he is looking at, hey, there's something interesting here. Let me play around this, okay? 1 second later, he's tried another thing. 3 seconds later, tried another thing here. And then, some interesting thing happens here because this thing becomes to send a lot of queries in 1 second, which means he began to use some automated tools, right? And when I look at the user agent here, it sees that Mozilla thing, so Intel Mac OS, Gecko, something, right? So that's interesting because it seems that normal browser user agent, but obviously user agents can easily change while sending a request because a lot of tools enables us to change the user agent. So he's using a fake user agent here, although he's using a kind of special tools to investigate the SQL injection here. Obviously, this is something that is familiar for many of us. So this is a SQL map generated code here. So he's using a SQL map and tries to, for a long time, to find out the potential exploitations, not only union or the stack-based or the union-based queries, but also error-based, time-based SQL injection as well. So it tries for a long time. Let's find out the latest logs, right? Let's take a look at the tail of his logs. Okay, he tried until this moment, right? So here, 1631. Oh, it's a lot of time. So here's another one. Here's another one. So obviously he tried some interesting thing here to get some results. Probably it's a successful exploitation because this union thing seems an interesting for me, and probably our server returned a lot of data, and it took only 2 milliseconds, probably 403. It's not a successful query. Okay, let me see. Okay, let's get some more here. Tail minus 100, and I will stay more here. So, as I said, grep by default it's a wildcard. That's why it takes some time while executing this, because dot is actually stands for a single character, right? So, for example, let me show you something interesting here. So for example, instead of 7 here, if I put 1 here and I say again same command, I'll get the same results because there is no 1.2 in my log file, but still I get this result because it includes 172, and this 7 stands for this dot. Okay, so as I said, grep by default it's actually a wildcard processor. So that's why if you're looking for 172 dot something, you gotta put a backslash here in order to make this thing work faster. So for example, this time it's going to take less than a second to get the results, as you can see, guys. So that's why, it's a good idea to use the backslash if you are not interested in wildcard. Okay, so here is some interesting exploitation again here. So he tried to exploit second time, I think, because that one is started at 9 something. This time it's running at 14 something and goes all the way down to, yeah, it's 1458. Yeah, it still continues. I think this is something. Let me see, it's 200. Yes, it's a 200, but the normal requests here. So he uses some dot here. Let's get here. Interesting. So he's not exploiting here, but probably he's investigating for something else. Okay, so we answered a number of questions here. First, we answered that our attacker tried to find some SQL injection, and he tried some accesses, and we know that he used some SQL map tool to find out the SQL injection, and he's using this IP address. The attacker is at 172.16.52. This is the attacker, and we know that he tried at least 137,000 of requests to our server, which is a pretty high number of requests. So that's pretty much we can find, while investigating this log file. I think that's good for us for now. We used the awk this time, caught, find for, and the regular expression, some Python here. And you may ask for hey, what is this XXD for? And if you guys are interested in dealing with some binary file like this one, and you wanted to take a look at that, and I also prefer to use a console to take a look at the binary representation of this log file. And I have a favorite binary representation. So for example, you can cat this disk thing, but please stay away from more or head here, because this is a binary thing. It's gonna mess up your console completely. Instead, I use XXD to take a look at the binary representation here. So for example, here, if I look at that, it's with this bytes here, it's the byte array here, and it's ASCII representation. So it's, as you can see, guys, this program cannot run in DOS mode. It's a backward compatibility for DOS 16 platforms. So again, if I say, let's say 480 bytes, so I can easily take a look at all the bytes here. So even if you are dealing with the binary file, you still can use the console to investigate those things. Of course, the binary analysis is completely different story. So you may need to use some static and dynamic analysis for that. We're gonna cover some courses in the later videos, but for this moment, let's assume that there's a way to analyze the log files as well as the binary files with the console, Linux binary console. All right, guys, thank you for listening me. So the next time we're gonna look at for some of the advanced topics, and we will deal with some real log files. And this time we're gonna take a look at some IDS logs and IPF logs, and we will investigate more potential problems. Of course, we're gonna get more Python stuff because we need to deal with some JSON format files. So those kind of files are really hard to play around with the console because it's a well format file, but it's really hard to process with the command line. That's why we're going to jump into Python a little bit more. And of course, we will take a look at some industry leading products like Splunk, and we already decided to run ArcSight. So those are going to be in our course content as well, and we're looking for somebody to tell us about QRadar. So those are going to be included in this series of threat hunting. Thank you for listening me. I hope you enjoy this video series. I hope this is informative for you. Thank you.